Hi guys. So,
my name is Yanover, and so for almost 2 years I worked at a company called Wiggle, which is a great company that does semantic product search. And I could tell a bit more about that later. I'm not working there anymore, so what we were working on was a fairly large piece of algorithmic code that was essentially parsing human text, so natural language text. And this code was shared between kind of our more researchy parts of the organization and the more production parts.
and so the engineers in the natural language analysis team, which include me, Vishai and Oren, we kind of developed a methodology of coping with the fact that there was this huge piece of code that had both kind of researchy parts and had also to run in production. So what I'd like to tell you about exactly that. So we kind of reached some ideas. Some of them are pretty complicated, so we won't have time. And other ideas are kind of concise, and I could state them here. So the premise is that to have long-term impact, you as data scientists are supposed to get stuff going for a long time, right? I mean, it's usually not just do this one analysis and stuff works. Do this one analysis and usually it's kind of left in production and should be delivering results till further notice. And from the data science parts, it means that you have to use sound statistical technique, you have to decode your outputs, things like that. And I'm not a data scientist, so I can't tell you anything about that. But from the engineering part, it means that your code has to be maintainable because realistically it will break. And the less time you'll spend debugging it, the better. So the whole point is making code that's, on the other hand, you don't invest a whole lot and it's still researchy and it's concise and elegant, and on the other hand, you kind of can make it work to production. Okay, so I'll discuss, without further ado, 3 techniques of doing that. Let's get to it. A lot of what I'm going to tell you about is about interfaces. Let's begin with an example. So what I'm going to do here is I'm going to show you a number of examples. Then I'm going to ask you, what are the subtle things that could go wrong? Because this is actually correct code. It's good in a meaningful sense. So what are the subtle things that could go wrong? I'll spend about 15 seconds to discuss that, and then I'll show you my ideas about it. Right, so what's wrong here? No, it doesn't have a bug, right? Okay, so the thing is like that. So I told you, it's subtle, right? It's okay. So the thing is like that. You're returning a dict to your users, right? So a dict in Python, up until a fairly recent version, is unstable, which means that when you iterate on it on different runs, you get the results in different orders. And it means that if you were to actually use this code in a production setting, then you would actually be getting different results unless you took special care to normalize them to reorder stuff, right? So that's a subtle thing. It could go wrong. So worth noticing. Another is that, for instance, consider the case in which one of the users gets the results, and then he decides to introduce some weighing, right? So he decides that the short words are worth more than long words, or vice versa. So, without thinking too much, he just modifies the data structure returned. Which means that, so if you were actually to store this data structure to cache it, then you would, so other users of the data structure would get a corrupted version. So again, there is nothing wrong with that code, but as an API, it could actually be broken because you would be expecting it to stay the same, and it doesn't stay the same. And there is another thing, which is like, say I get a dict from you with strings like on the key part and integers on the value part. And I don't really know, like, I mean, I get it from like 15 layers of code down, and I don't really know what those integers mean. I mean, so that's another problem. So, okay. Yeah, and so what I wanted to show you is kind of a more future-safe way of doing that, and it's less efficient in terms of like runtime performance. So often it doesn't really matter that much. So there is a very nice package called attrs in Python. How many of you have heard about it? That's what kind of break, right? So attrs is an excellent way of defining a structure with so essentially a class with a given set of attributes and with certain semantics of how do you set them and what attributes are correct. For instance, you could only allow counts that are integers, so none as counts. And also you know when you receive such an object that the word part is attrs object dot word, so unigram count dot word, and the count is dot count, so you know that it's a count and not something else. If you were to like desire it for something else, you would call it something else, right? And another thing you can do is so another thing you get from attrs is it creates a constructor for you, and it creates validators to the extent that you ask for validators. So you can't make a count of which is a floating point number, and you can convert values. So it's pretty convenient, trust me. Okay, so and what you could actually do to get the code future-proof, what we would write in Twiggle for this specific case is we would kind of put the results in an order dict, so they would be sorted by the order that you see the tokens. And you would then repack that into a tuple of unigram counts, which is pretty unambiguous. A tuple is immutable in Python, so the value that you return here, it's going to be like even if it's cached, it's going to be incorruptible, right? So that's kind of any questions about that? Yeah.
What version of Python are you using in Twiggle?
So let's talk about that later. It's like a good question, but for later on. Yeah.
Why did you need the unigram count?
Well, you're just making a histogram of words, so I want to know what word is frequent in your text. This is actually a pretty frequent thing to do when you are analyzing some kind of linguistic phenomenon. Yeah. Right, so I'm going to move, and I'll show you a code example, and I would like to move to slightly more subtler ground. And so typing is kind of a contract between yourself and other people includes you in a couple of months because you don't really remember what's in that dict that you made. Specifically doing, so one option that attrs gives you is doing type checking. You could be doing like instance of, so that your counts are integers. It means that you're introducing a performance penalty because instance of costs some microseconds. So one choice is saying that it doesn't really matter. Another choice is there are some pieces of infrastructure like Spark data frames that guarantee your data type consistency, so we could be using those, right? But it's another strategy, it's to the same end. Yeah. Right, and even a more general approach is, so almost any kind of interface you have with a file, it involves serialization, deserialization. So how many of you had used the Python pickles? Right, so everybody knows about pickle, so it's an easy choice, but it's also Python specific. So you could be using a number of other formats which are not Python specific, but then you would actually need to map Python data structures to that format, right? So for instance, to JSON, you would be using Marshmallow or something like that. Okay, so the good news is that it's not that difficult if you're using attrs to make something that converts attrs automatically to JSON, and you would actually be so actually it's a part of the attrs library, which is attrs as dict with the recursive option. But in a more general case, it's not that difficult to make it, and it makes your code infinitely more readable. So at Twiggle, we developed the whole serialization library that used attrs as a type annotation. We considered well, when I was there, we considered open sourcing that. It didn't happen, but it's kind of not that difficult to do something similar. So, in any case, I do implore you never to use CSV, so like comma-separated values, if that option is available, if any other option is available, because really CSV is the worst format ever. Does anybody disagree on that? Yes, yeah.
Maybe XML, SAML page.
No, I want to stand the record that XML is, in some senses, better than CSV. So the next thing I wanted to talk to you about is memoization. Right. So how many of you had written code that looks like that? Okay. Right. So by that I mean that you have a kind of a global dict and then a global singleton, and then you're kind of like you begin your code by checking if the data that you want, the data that you want memoized is in that dict, and then you kind of, if it's not, then you calculate and then put, yeah. So okay, so why is that code? What's the problem with that code?
Let's say to make sure that it's clear. Global state.
Yeah. Right. So yeah. Okay. So global state is a very good answer. Thread safe is also a good answer. So it's like it stems from essentially their same function doing two different things, which are like totally disjoint, and one of them is actually not a data science like thing at all. So one of so the first thing is kind of calculating the bit count of an integer, which is like for that purpose a data science thing, and the other is storing it in some kind of a cache, which is not a data science thing. I mean, it's partially, but the choice of which cache exactly to use is not a choice that like you should leave inside your module. And why is that? Because the lookup table can grow to essentially an infinite size, right? So in Python, like integers are like arbitrary length, and even if they were limited to like say 32 bits, then again you would probably get out of RAM before you fill that table, which isn't necessarily a good thing, right? It's like, so the specific thing there is actually is thread safe. But if you were to do something kind of more complicated, then you could be becoming not thread safe. So the good news is in Python you actually have like one basic library for doing cache in Python 3, which is called LRU cache inside functools, which is a wonderful module in any case. And for Python 2 you have a library called cache tools, which means that you would be decorating your code with like a decorator that looks like that, and you would both those libraries, they have means to constrain the size of your cache, and they also have means to pass around a factory function for creating the cache. So you could be injecting that factory function. I'll talk about that in a couple of slides, what it means to inject stuff. And you could actually take care about the dimensioning of your caches elsewhere in the system, which is a good thing because like it's not always apparent when you're going to run out of memory and who are going to, like the principal users. Okay, any questions about that? Yeah.
It also have some kind of global environment holding the cache. Or it's just hidden?
So here, actually, there is a static variable called in the cache. It's called count once, and it's a functional composition of a function that looks up a certain dictionary and this function that you see here. So you still have a global cache, which connects me to the next slide. Yeah.
Wouldn't it be better to wrap it in a class?
Well, yeah.
When you want.
Yeah, so the problem with wrapping this in a cache, in a class, means that you'll be rewriting the same logic of like check if stuff in the cache, and then you'll be writing the lookups explicitly, which is kind of which could introduce a lot of variance between different people doing that inside the same code base and make it difficult when you decide to readjust the cache sizes to see how to do it. So it's possible to do it in a class and have the relevant cache and instance variable of that class. It's slightly less elegant, so but let me get to the next slide and then I have some notes about that. Yeah, so first of all, that's more or less the better way to go. So it's not a silver bullet. Cache tools are not very nice about caching complex objects. So they have to cache, you need to calculate the hash of the key, of the objects that you're passing to the function, and their implementation is not that good. It was something that Tel Aviv, one of the guys that was working with, discovered. So it's not kind of perfect for every use case. You could write your own function, which probably would be better. And the whole thing works only for static functions, so module level functions. And it will break horribly it won't really break on instance methods, but it will cause a very serious bug because it will essentially mean that you're keeping an extra reference to that instance, right? You'll be, because all instances in Python receive a self pointer, right? Self-reference. And then it would mean that you're leaking instances of whatever thing you're caching this way. So that's not very good. In Twiddle, we wrote, we used some dark Python magic and wrote a decorator that creates a hidden instance attribute and puts stuff there. So a special handling for this specific problem. One thing I wanted to mention also, which is kind of orthogonal to everything I talked about, is that if you rely on huge caches, then you should consider storing them on the disk explicitly and not relying on paging and stuff like that. And there is a great library called LMDB, which is a key value store that's very high performance, and you can just put stuff on your disk. It's extremely quick. It's written in C, and so that's a very nice strategy. Right. Okay, so here is we arrive at the next section, which is about dependency injection. Okay, so there is actually nothing wrong in this code. Yeah, so it just, it processes some data and it logs some stuff. But first of all, it's not kind of compliant to best practices with respect to logging. And also, so there is something here that it's probably not kind of the best thing. The logging is not the right tool here, because you're logging how many records you got for your data, and it usually means, so this is fine. This is fine as long as you're running your own data pipeline on your own machine. But probably when you're running stuff on your production environment, you would want to write this down as a business metric, right? Like how many records you processed on any given location. So it's not really stuff to be logged. So that's one problem that we see here. But that's not the reason I showed you this code. Actually, I wanted, so this code has something nice, and it's pretty obvious and pretty hidden. So it has actually this magic object, a module logging, and you get good stuff out of it, and it's just there, right? You don't need to do a lot of work to get it there. So and somebody else takes care of setting it up for you, right? So in your main module, you configure it, and then if you want a different configuration, you could do it a different configuration, and then your code just can access that. Right? So am I making sense here? Any questions? Yeah. So this is important for the next part. So first of all, the right way to do logging is by creating a logger per module. So then you can see when you get the stuff logged, you can see what module created that. So this is this piece, right? You do a get logger with name. That's the standard idiom for Python. But the more important part. So there is a more advanced technology that's called dependency injection, and dependency injection is a way of passing objects to inside your code, which you kind of take care about very explicitly. So you can be very picky about what objects you pass. It's not just like a global variable like the module logging. You can be very fine-tuned about what you get and where. And the way it works is like that. So in this example, I created an auxiliary object called task execution resources, which is a bunch of stuff that's probably useful for you when you're running a data pipeline. So it includes some kind of metrics sync. So metric sync is something that you can send metrics to, and it includes a data source. And then you do some helper logic, and your code looks like that, right? So in this specific framework, which is open source by Twiggle, you get your metrics passed. So your context is passed to you as arguments to your function, and then you can just fetch your data like this. So you can just access the right data source pops up inside your code without you actually asking for a specific data source. So where does that come from? So that comes from this part. You are declaring that for the purpose of this task context thing, your metrics will be this thing and your data source will be this thing. And then when you come to your code, you kind of just can use them without asking for a specific data source or metrics engine. Is this making sense? Yeah. So, yeah. And then when you are kind of reaching production, then you won't need to change a single line in your data science part. You just need to pass more serious objects as your metric sync and as your data source. So that's kind of the gist of it. So we're near the end. So the main points that I'd like you to think about, if I'm doing my job right, is your code is really a contract between you and people maintaining that code, which could also be you, but could also be other people. And so what I'm showing you here is the kind of an ethics of how to demarcate or how to put a border between stuff you do and and stuff other people will be doing, so that you're kind of constructively helping each other and enabling them. So yeah, so that's one idea, which is, by the way, something I deeply believe in. So we should be helping other people and making their lives easier. The second thing is that you should consider your internal data structures, which are good for processing stuff, as separate from those that are useful for accessing stuff, and consider the kind of abuse that accessing stuff entails. So, for instance, your users could be overwriting your data, things like that. So you should probably be you should consider at least what would happen if a user kind of deletes stuff that you cached, or which is worse, writes stuff over stuff that you had cached. Okay, so, and also things that I didn't touch completely and are pretty important, so I should pay homage to that. If you didn't learn yet about how doing test-driven development, I strongly recommend that you do. And in any case, naming convention is, if we speak about helping other people, that's kind of the number one way of doing that. Yeah, and those are the takeaways. Yeah. Any questions?
Well, what happens to your dependency injection field code when you try to use some forks, multi-processing, or you try to execute these on class, like Spark or
Yeah, so Twigo was actually using Spark to. I mean, I was using Spark at Twigo to. So it works. You should remember that anything running in PySpark in the end is regular Python code. So you will. So if you want that variable to be initialized, you will need to arm it with the right metrics and stuff like that. And the library specifically is thread safe, so it was written with multi-threading in mind. And with respect to multiprocessing, so each of the processes, if you arm it before you fork, then the processes share that resource, and if not, then it's kind of initialized in each of the sub-processes.
And on Spark, would initialize default, sending it to the cluster, or
it kind of depends on what you do, right? Because you know what? Let's take it offline. So in Spark is about calculating functions, right? So it practically means that. No, I'll answer now. Spark is about calculating functions, right? So and these functions don't come with the context of dependency injection with them. So you always would initialize this thing inside your function. So what you usually do in Spark is you just cache, so you memorize like the things I showed you, you cache the relevant context. So it doesn't have to be recalculated each time you make the PySpark function call. And then you just use the cached value to arm your injection and use that inside your code. Yeah, so that's
I'm reading between the lines if you're using Python 2 for some reason. A lot of the problems are solved with Python 3.
Could you elaborate? Because
for example, LRU cache is a part of the standard library.
Yeah.
Type hints, data classes.
Yes, so Python type hints are very nice. If you don't know about type hints, use them. And Python 3.7 has data classes, but the thing is that you sometimes want to validate the values that you're getting in runtime, because type hints won't protect you from a bad piece of code passing your stuff around. It's useful as a hint for developers and for some static type checking code, but if you get to a large enough code base, and we had gotten to a large enough code base, then you'll be kind of you would have kind of UFO objects getting past you. So, and type hints won't help you.
Is there a reason to stick with Python 3?
Well, one reason that was often mentioned, when I was discussing that, was that Python 2 is still slightly more efficient, and if you're running a very high-performance application, which Twigo is, then you do care about every inch of performance. Okay. Thank you.